much North and South Pole pretty much just melted, and the equator like spreading out from pole to pole.
Right? Somebody else expand on what Drew said. He said the North and the South Pole melted, and the equator expanded. He's off to a great start. What else happened, Luke?
The equator rose to the top, and the North and South Pole went down to the bottom.
Yeah, Luke said that the North and South Pole sank, didn't they? And you can see that right now. Do you see the blue kind of on the bottom settling? And what's the equator doing? It's kind of hanging out on top, isn't it?
Yeah.
Well, let's talk about what happened. Give me your good attention. Here's why this happened. If you are a cold air molecule, or if you're a cold water molecule, think about what you're like when it's cold outside. I know you didn't have outdoor recess today, but when you're outside and it's cold out, what do you do? Do you huddle with your friends sometimes? Because you're trying to what? Get warm. What's it look like when you're outside? A lot of people are really close together, aren't they? If you're a cold air molecule or a cold water molecule, you're very close together, and that makes you very heavy. So that cold air or that cold water is kind of like a bully, and it sinks to the bottom and does what to the warm air or the warm water? It pushes it up. It's a big bully and says, get out of my way, I'm pushing you up to the top. Think about when you're outside at recess, it's a warm summer day or a hot summer day. What do you tell your friends? Back up, get away from me. Do I want you huddling all up in my space, in my bubble, whenever it's a hot day? No way, I need my space. Kind of like when I do read aloud, and I ask you to come up real close around my chair. In the summertime, I don't ask you to do that. I love you, but I want you away from me because I need some air so that I don't sweat, okay? Think about when you're in your house, and it's the summertime, where do you go to get cold? Where do you go, Luke?
Air vent.
To an air vent, or if you don't have an air vent, where can you go? Matt? Okay, inside your house. You can go to a pool or an air vent, but if you just have the rooms in your house, where do you go to cool off?
Window.
You guys are killing me here!
Oh, basement.
Thank you! You go to your basement, don't you? If you need to cool off, I know in my house, because my basement's under the ground, I go to the basement. Kirsten's shaking her head, She goes to the basement to cool off. Think about where's the hottest place in your house. Help me out on this one, Sammy.
Attic.
In your attic. If you ever go to your attic on a warm summer day, what's it like? Lindsay's doing it. It's very hot up there. Well, here's what happens. Warm air always rises. It goes to the top. Same happened with our experiment here. My bin was full of warm water, wasn't it? So when I put in the dye, it was the warm water that was rising because the ice cubes were very cold and being the bully and saying, get out of my way, I'm heavier than you are, so I'm going to the bottom. Show me what the molecules do on a cold day. They're very close together and they're very heavy. So they're the bully and they say, get out of my way. But if you're a warm molecule, you say, show me with your hands, get away from me. Back up. Somebody, in your own words, tell me what just happened in that bin. I explained it in my words. I want to hear it in your words. Taylor, give it your best shot.
The red went to the top because of the hot, because of the cold air coming down.
You're off to a great start. Keep going.
And the cold air went down because it is colder
And
and heavier down at the bottom.
right. Did you ever hear the word density before?
No.
If something is dense, it is very heavy. If it's not dense or less dense, it is lighter. Which one was more dense? Was the ice cube blue food coloring more dense? Or was the equator, the red coloring, more dense? The ice cubes, because that was the big bully that sank to the bottom and said, get out of my way. We're going to do another experiment to show density just like that, things that are more or less dense. So what I need you to do is remember everything we learned from this first experiment. and use your brain power and your knowledge to help me make another prediction. Can you do that? I need one person, Mrs. Caldwell, to care